Okay. So first of all, a force is a push or a pull. So like quite straightforward, right? If like I just push you away or I pull you forward, that is a force.
Mhm.
Okay, so what a force can do is four things. It could move a stationary object, means like if I have a ball over here and it's not moving, and if I put a force on it, it will start to move. So that's moving a stationary object. So it can speed up, slow down, or change direction of an object already in motion. So means if my ball is already rolling, if I add a force onto it, it can either roll even faster, or if I put it in a different direction, it will slow down, or I could like knock it in a different direction so that it will change direction also. Yeah, so it could do these three things. And then another one is if I put enough force, I could even stop a moving object completely. So my ball is rolling and I like put a force there, then it can stop. Either that or it can change the shape of an object. Like your Play-Doh, like if you go and like press, it can change the shape. So yes, this is the four different things that a force can do. Okay, then the three things that I think your level will go through is these three types of forces. So first one is the force in springs, then will be gravitational force, and then be frictional force. So okay, so we go through one by one. So first, the force in springs is like the more scientific term for force in springs is the elastic spring force. Okay, so the definition, right, is that it's the force acting on a stretched or compressed elastic object to return to its original length. So that means if I take a spring, right, and then if I press it until it's very, very small, it will put a force in the other direction because it wants to go back to its original shape. So the same thing, if I pull it longer, it will also exert a force because it wants to go back to the normal shorter state. Okay, so the different things affecting the elastic spring force in the spring, right, is the extent of stretch or compression. So if I compress it a lot, means the force will be a lot. So, but if I push a bit only, means the force will be only be a bit. Same thing for the stretch. And then another one is the stiffness of an object. So I don't know if you got like play with springs before, but some like you realize it's very loose, but you put a bit of force can already.
Mhm.
Like example, your pens, like when you click the pen, there's a spring inside. And like you don't have to use a lot of force because the spring is quite weak. But like other things like like bigger, thicker springs, you have to push it very hard before it will like compress. Yeah, so that will affect like how much elastic spring force is inside. Okay, so okay, another thing is right, like example, if the object is stiffer, means you have to put more force onto it if you want to compress it. So example, I have a spring that is very, very stiff. And if I want to compress it by a bit, right, I also have to put a lot of force. Yeah, so that's how the stiffness affects that. So more stiff it is, the more force you need to put for it to compress or expand. Same thing if I press it a bit, right, and then I ask you how much force is it, means if it's stiffer, means it's a lot more force. Okay, then for the direction, because this force in the spring, right, it has a direction. So if the original, I tell you that is like, if the original is this length at the dotted line, and then if I compress it until it's smaller, that means my force will be acting towards the dotted line. Yeah, so it'll be acting back towards the dotted line so that it will go back to the original shape. And then if I pull it longer, then it will want to go back to the original shape. So same thing, the force will point towards my dotted line again. Okay, so always remember that the force will just point towards the dotted line if you want to know the direction of it. Okay, so now I got a quick quiz. Okay, just to see whether you understand. So, okay, the spring on the left is stiffer. Okay, like the two springs on the left is stiffer. Which spring has more elastic spring force acting on it if both springs are compressed to the same height? So that means okay, both of them are like were longer lah.
Mhm.
Then after that, I put a force on each spring
Mhm.
until they are the same height.
Mhm.
So which one has more elastic spring force acting on it if my left one is stiffer?
The right one.
No, it's the one on the left.
Oh.
Yeah, remember because I mentioned that if it's stiffer, you have to put more force onto it to press it to the same height.
Okay.
Yeah, okay. So like if you imagine maybe like okay, like you got play with springs before, right?
Yeah.
So maybe you imagine yourself playing with like a really, really stiff spring, like the metal is like super, super thick. Then you want to press it, right? You have to put a lot of force to press a bit, correct?
Yeah.
Yeah. So if then you imagine yourself playing with a smaller spring, like a very thin one, maybe the spring from like your pen.
Mhm.
Then that one you just use your finger, you press a bit, it will compress all the way already, correct? Yeah, so if I want to press both springs to the same height, so it means I compress by the same length, then that means the one who is stiffer, I need to put a lot more force. So that means there'll be more elastic spring force on that one also. Get it?
Mhm.
Yeah, okay. Okay, so that's for